Hello students, so let us solve this question. So first question they say, the figure shows certain wire segments join together to form a coplanar loop. The loop is placed in a perpendicular magnetic field in the direction going into the plane in the figure. The magnitude of field increases with time. I1, I2 are the currents in the segments of AB and CD then. Okay. So basically this is AB and this is CD. This point is D. Okay. So if I draw the loop looks like this. Okay, I'm drawing little bigger. Okay, like this. Okay, so here you can see the magnetic field is inside and inside is increasing. So if inside is increasing, I need to give some outside field. So induced current in AB. How should be the induced current in AB to give some outside field? Answer is this way, correct? So that it can give some outward field. Similarly, in case of CD, the current should be in which direction? Should be in this direction. You can apply right hand thumb rule so that it can reduce the increasing field. Okay. So what is the concept? Induced current, induced current tries to decrease the flux. Okay. Decrease the flux. So option is I1 is in the direction of AB and I2 is in the direction of D to C. Option D is correct. Second question. Two metallic rings A and B, identical in shape and size but having different resistivities ρ A and ρ B, are kept on a top of two identical solenoids. When current I is switched on in both the solenoids in identical manner, the rings A and B jumps to height HA and HB, where HA is greater than HB. The possible relations between their resistivity and masses. So you can see these two rings here. If I draw these two rings, A and this is B. So A rises to a height of HA, B rises to a height of HB. Here they have given HA is greater than HB. Okay. So first of all, why the rings will jump? Because because of induced charge or induced current, you can say. So as soon as I am switching on the current in the solenoid, the flux through the ring is changing. So to decrease the flux, it will go up basically. You can say like that. Or you can also say the induced current and current in the solenoid will be in the opposite direction, so they'll repel. They'll repel. That also you can find direction of induced current. Okay, now what will be the induced current? Induced current will be E induced EMF, that is d phi by dt, correct? D phi by dt divided by R. Okay. So can I write I equal to d phi by dt is induced EMF due to change in flux of current passing through solenoid divided by R is rho L by A for the ring. So I is inversely proportional to rho, correct? Rho. Okay. So here you can see that HA is greater than HB. So I can say IA, current in A is greater than current in B. Obviously, if more current, repulsion will be more, correct? Because repulsive force depends on I1 and I2, both, you know. So here, if current is inversely proportional to rho, current in A is more. So can I write rho A is less than rho B? Yes, I can write. And what about mass? Mass can be equal or mass has to be less. Okay, if mass is greater, it may not go to the greater height, correct? See why? Because when the ring is jumping, it has to do some work against the gravity, that is mgh. Okay, from where that energy is coming? That energy is coming from this energy of induced current. Okay, so it can be equal or less, it should not be greater. So option B, B is not correct. B is B can be correct, and D also can be correct. Both are fine. Okay. Let us solve the next question. Conducting loop in the shape of a right angle isosceles triangle of height 10 centimeter, kept such that 90-degree vertex is very close to infinitely long conducting wire. The wire is electrically insulated from the loop. The hypotenuse of the triangle is parallel to the wire. The current in the triangular loop is in counterclockwise direction and increased at a constant rate 10 ampere per second. So, first of all, there is an infinite wire. Direction of current is not given. So, there is a loop and current is in anti-clockwise direction. So, first option they are saying the induced current in the wire is in opposite direction to the current along the hypotenuse. So, you see, because of anti-clockwise direction, what is the field? Field will be outside, correct? Now, current is increased. If current is increased, B outside is increasing. So if B outside is increasing, I need to reduce that. So current, induced current in the straight wire will be in which direction? Because I need inside field. It will be from thumb rule you can apply. This will be I induced. Okay, so that it can give some inside field. It can reduce the outside increasing field. Okay, so current in this hypotenuse and current in the straight wire is in parallel direction. So option A, they are saying opposite direction, which is wrong. Hmm? Option A is wrong. Let us say option B. There is repulsive force between the wire and the loop. Okay. So this is the straight wire. Now current is in anti-clockwise direction. So obviously due to induced current and this current, there will be attraction. Okay. If attraction. Okay, I'm just writing in short. But what about the other two where if I take component of this wire will be like this, correct? And component of the other wire will be like this. I don't have to consider these two vertical components, not needed, only the horizontal component you see. Here induced current is in this direction, right side, and current in this is the opposite direction. So they'll repel. Here also, because of this, they'll repel if repel. है ना? But which will be dominating if attractive or repulsive? Repulsive, because you can see this wire is more closer. Can consider this a small part of wire. It is more closer to the straight wire. So repulsive will be dominating. So B is correct. There is repulsive force between the wire and loop. B is correct. Let us see option C. If the loop is rotated at a constant angular speed about the wire, the additional EMF mu naught by pi volt is induced in the wire. Okay. So if loop is rotated, understood? Is there any EMF? No, I don't think so. Because why? Because if I rotate this loop, correct, what happens? Here, whatever was the field is increasing, due to that there will be induced EMF. But due to rotation, if I rotate this about this wire, due to rotation, is there any extra change in flux? No, there is no extra change in flux. Correct. There is no extra change in flux. So no induced due to rotation. Okay. So option C is wrong. C is wrong. Now option D they're saying that the induced EMF magnitude of induced EMF in the wire is mu naught by pi volt. Okay. So I have to find magnitude of induced EMF in the straight wire. So just try to think how we can do this because field through this loop is increasing. How we can do this? Because of change in current in one, there is induced current in another. So basically, I can apply the concept of mutual inductance. Mutual inductance. Okay. So let us try to find mutual inductance of this. Okay. So this is the straight wire, correct? Okay. Now current is not okay. Suppose this is I. Okay. I1. What is the flux? Flux through loop. है ना? This angle is 90 degree. So if I take at a distance of x, at a distance of x, okay, this will be 45 and the upper one will also be 45. Okay, see this diagram very clearly. If I consider a small element of thickness dx at a distance of x, so this angle will be 45. This angle will also be 45 because the whole angle was 90. You know that. So if this is 45, this is 45. If this is x, this also has to be x. Similarly, this is also x. So what is flux? Phi. Phi. Phi will be mu naught I by 2 pi x. Current is I1 here, okay? Now let mu naught I1. Mu naught I1 by 2 pi x into 2x dx. This is the phi, okay? So phi equal to mu naught I1 2x and here 2x cancel by pi into dx. Okay, from where to where? X is running from 0 to 0.1 meter because I think it's 10 centimeters. You can see, yeah, 10 centimeter. Dx will vary from d phi integration of d phi 0 to 0.1. So mu naught I1 by 10 pi. So can I write phi equal to m I1? Correct. So from here, what is the value of m? Mu naught by 10 pi. Okay. Now using this m, value of m, I'll try to find induced EMF in the straight wire. So induced EMF in straight wire will be m into di2 by dt. Current in the loop is suppose I2. Correct? So m is how much? Mu naught by 10 pi. And what is di2 by dt? di2 by dt is given. That is 10 ampere per second. So you write mu naught by 10 pi into 10. 10 10 cancel. So you are getting mu naught by pi. So this is the induced EMF in the straight wire, which is absolutely correct. So option D is correct. So here answer is B and D. Both are correct. Third question done. Okay. Fourth question. Fourth question. A rigid well loop of a square shape having side capital N and resistance capital R is moving along the x-axis with a constant velocity v naught in the plane of paper at t equal to 0. Right edge of the loop enters the region of length real where there is a uniform magnetic field B naught into the plane of the paper as shown in the figure. For sufficiently large V naught, है ना? Sufficiently large means it should not be stopping before crossing the distance 3L. Loop eventually crosses the region. Let X be the location of right edge of the loop. Vx, Ix, and Fx represent the velocity of loop, current in the loop, and force on the loop as a function of X. Counterclockwise current is taken as positive. Okay, okay. Which of the following schematic plots are correct? So where is the schematic plots? These are the plots. So first of all, before going to these plots, I'll try to find what is the velocity as a function of time, okay, or function of x. Velocity as a function of x, force as a function of x. These two things, if we can find the equation, then it will be easier to plot the graph. Okay. So here there is a resistance here R loop. This loop is entering into the magnetic field. Initial velocity was v naught. At any time when it enters the loop, what will happen? Because of change in flux, there will be induced current, and induced current will be in the counterclockwise direction, which is taken as positive. Now what will happen? Because of induced current, there will be force in this direction, opposite direction. So velocity will decrease. So I can say at any time the velocity is v when it entered the distance x inside the loop. Okay. What is change in flux in this case? Phi equal to L x b naught. Correct. Area. Just this area. Length is L. Correct. Length of this is L. Okay. So I can write L x b naught is the phi. What is induced EMF E? E equal to d phi by dt. So can be written as b naught. Magnetic field is b naught. Yeah. B naught L dx by dt, which is B naught L V. Okay, B naught L V. Okay, now what is the force? Force is equal to minus I L capital L B naught, and current is B L V by R. B naught L V by R. E by R. Current. So put the value of current. So force, what you get? Minus of B naught square L square V by R. This is the force. So force can I write force mass into acceleration? Acceleration is V dv by dx. V dv by dx. Because I have to find a relation with x. Okay. Minus B naught square L square V by R. So V dv equal to minus B naught square L square V by mr dx. 0 to x, changing from V naught to V. Okay, V naught to V. Acha, V dV, one V is cancelled here, correct? So you get only dV. So V minus V naught equal to minus B naught L square by mr into x. So can I write V equal to V naught minus B naught L square mr into x. So basically V equal to V naught minus Kx. K is a constant, है ना? Or Cx you write. Cx. C y equal to mx plus c if you see. Here slope is negative. Okay, slope is negative and it is decreasing. V is decreasing. So here I have got the equation of V. Okay, velocity is decreasing. What is the force? Force equal to B square L square V by R. So force can be written as B square L square by R. What is V? V can I write V naught minus Cx. So force is also for force negative slope. For force also there is negative slope. Okay. Force is what? ILB equal to B square L square by R V naught minus Cx. So what will be the current? L one L cancel. Current B1 B is also cancel. Current will be BL by R V naught minus Cx. So also this is negative slope. Correct. So basically force, you can see force, current and velocity, they will be similar. Graph will be similar. Okay. But force is in which direction? Force is in negative direction first. Okay. And velocity is positive direction. At x equal to 0, velocity is in positive direction. Okay, we know. So if I try to analyze the graph, first graph is wrong. Why wrong? Because when the loop is coming out, the direction of current should change. Direction of I will change. Okay. Because initially the flux is increasing and when it is coming out, flux is decreasing. So direction of current should change. Correct? No? To oppose the change. So option C is correct. Option B is correct. Force will decrease. In between L to 3L remains constant. Huh? In between L to constant means force is zero because no induced current. Induced current will be zero. When it is between L to 3L. When it is traveling from L to 3L, no change in flux. D. Initially velocity decreasing remains constant. After that again it will decrease. D is also correct. So answer is B, C, D. Okay. Next question. Two identical inductors L1 of inductance 1 millihenry, internal resistance 3 ohm, L2 2 millihenry, internal resistance 4 ohm, and resistors of 12 ohm are connected in parallel across 5-volt battery. The circuit is switched on at t equal to 0. The ratio of maximum and minimum current from the battery. So basically you have inductor, 1 millihenry, 3 ohm. Okay. This is 2 millihenry and 4 ohm. And resistor 12 ohm. All are connected in 5-volt battery. Okay. All are connected in 5. So at t equal to 0, inductor acts as inductor acts as open circuit. Basically it opposes. So current will be what? Current will be minimum or maximum? At t equal to 0, current will be minimum because resistance will be minimum. Resistance will be maximum. Why? See, resistance 3, 4, 12. If parallelly they connect, definitely resistance is going to decrease. Correct. Now if I remove 3 and 4, only 12. So this will initially it will give I minimum because inductors will oppose. Correct. It will oppose. So I minimum will be 5 by 12. At t equal to infinity, inductor has offers only resistance. Correct. It acts as simple wear, but there is a resistance of inductor also. So it will have only resistance. Otherwise, inductor has no effect otherwise. So at t equal to infinity, current will be maximum because then resistance will decrease. So what is the R equivalent? R equivalent 1 by R equivalent will be 1 by 3 plus 1 by 4 plus 1 by 12. So R equivalent, if you solve this, R equivalent you are going to get है ना 12 divided by 4 plus 3 7 plus 1 8. Yeah, so you get 3 by 2. So R equivalent you got 3 by 2. So I max will be what? I max will be 5 by 3 by 2. That is 10 by 3. Now they are asking ratio of I max by I min. I max by I min. 10 by 3 divided by 5 by 12. है ना? 10 by 3 divided by 5 by 12. Okay, 4. So answer is 8. Question number 6. A circular insulated copper wire loop is twisted to form two loops of area A and 2A. At the point of crossing, the wires remain electrically insulated. The entire loop lies in the plane of paper, uniform magnetic field into the paper. This. Loop is rotating with omega. Okay. So if loop is rotating with omega, I'm considering this is E1 and this is E2. E1 and E2 in the loop. Okay. What will be E1? E1 will be phi, phi 1 is B into 2A cos of omega t. Okay. So E1 is what? 2BA omega sine of omega t. E1. What is phi 2? Phi 2 is BA, area is A, BA cos omega t. So what will be E2? E2 will be BA omega sine omega t. Now you can see the current due to induced EMF will be current will try to when it rotates from this plane the current will be the inside field is decreasing, inside field has to increase, so current will be in this direction. Okay, when it just starts rotating, I induced. Obviously, it will be AC current, it will change the direction because it's periodic EMI. It will generate AC, AC source. So initial direction of current is like this. Now you can see that if current is loop B, okay, I'm considering in loop 2. This is loop 2, this is loop 1. So current in loop 2 will tend to oppose current in loop 1. Okay, will tend to oppose. Come this side, go this side. है ना? So what will happen? Net induced EMF will be E net will be E2 minus E1, which is equal to BA omega, and I can write E1 minus E2. E1 is greater here. E1 minus E2 BA omega sine of omega t. है ना? So let us see first option. The rate of change of flux is maximum when the plane of the loop is perpendicular to the plane of paper. Yeah. So E is max when sine omega t equal to 1. Sine omega t equal to 1 means what? Omega t equal to pi by 2. That means plane of loop is plane of loop is perpendicular to plane of paper. Okay, so option A is correct. Option B. The net EMF induced due to both loops is proportional to cos omega t. No, it's proportional to sin omega t. B. E induced है ना E net is directly proportional to sin omega t. So option B is wrong. Option C. The EMF induced in the loop is proportional to the sum of areas. No. Induced EMF, if it is sum of areas, then it will be 3 BA omega sin omega t, correct? But it is BA omega, so it is wrong. C is also wrong. Okay. Answer will be subtraction of areas. Proportional to subtraction of areas. Option D. Option D. The amplitude of maximum net EMF induced due to both loop is equal to amplitude of maximum EMF induced in the smaller loop. What is induced EMF smaller loop? BA omega sin omega t. What is E net? BA omega sin omega t. So amplitude of maximum net EMF due to both is equal to amplitude of maximum smaller loop alone. Correct. So answer is correct. No? Answer is A and D. Question number 7. A source of constant voltage V is connected to a resistance R and two ideal inductor L1 and L2 through a switch S as shown. There is no mutual inductance between two inductors. The switch S is initially open at t equal to 0. The switch is closed and current begins to flow. Which of the following options are correct? L1, L2 है ना? Switch is closed at t equal to 0. Current begins to flow. Okay. So what will be the steady state current? First one, the ratio of current through L1 and L2 is fixed at all time. So let us see option A, ratio of currents, correct? So for option A, can I write? Voltage across this both will remain same. Okay. Voltage across both, V across L1 and L2 is same. L1 di1 by dt equal to L2 di2 by dt. So I can write from here, if I just integrate it, L1 I1 equal to L2 I2. So I1 by I2, I get L2 by L1, which is fixed. Okay. So option A, ratio of current through L1 and L2 is fixed. This is correct. Na? Option B, after long time the current through L1 will be V by R L2 by L1. L2 by L1 plus L2. Okay. Let us check option B. Okay. I'm considering current in this is I1, current in this is I2, total current is I. So can I write I equal to I1 plus I2? Yes. What is I? After long time at t equal to infinity, I will be what? V by R because inductor will act as short circuit. Correct. See the diagram. Inductor both acts as simple wire. So current in the circuit will be V by R. So V by R equal to I1 plus L1 I1 equal to L2 I2. So from here I2 is how much? I2 is L1 I1 by L2. है ना? So V by R equal to L2 plus L1 by L2 I1. So I1 you'll get V by R L2 by L1 plus L2. Check V by R. Yeah, correct. B is correct. So similarly, I2 also you can find. I2 will be V by R L1 by L1 plus. This is also correct. B, C correct. D at t equal to 0 current through the resistor is V by R. No, at t equal to 0 inductor fully opposes current will be 0. This is wrong. So answer is A, B, C. Okay, we have to finish quickly. Let us solve question number 8. The conducting wire of parabolic shape y equal to x square is moving with v equal to v naught I cap in a non-uniform magnetic field b equal to v naught. Something they have given. V naught, B naught, L and beta are positive constant and delta phi is the potential developed across the ends of the wire. Correct statement. Okay. So whenever this kind of thing is given, B is given out of the plane, V is V naught I cap. What you have to do? You have to take the projected length. Take projected length. Projected length will be what? This L. है ना? Because velocity is in this direction. V naught I cap. Okay. So let us see first. Delta phi remains the same if the parabolic wire is replaced by a straight wire y equal to x initially of length root 12. So if I take y equal to x, length is root 12. Its projected length will be root 12 sine 45, which is equal to L. So projected length is equal to the initial projected length of the given system. So A is absolutely correct. Okay, A is correct. Second, B. Delta phi is proportional to the length of the wire projected on y-axis. B is also correct. B is also correct. Okay, because projected length along y-axis is L, correct? So delta phi is what? Delta phi will be B L into dx. Okay, if I consider it's moving through a small distance dx. Okay, dx will be v naught into t, v naught dt. So delta phi is proportional to L, projected length on y-axis, correct. C, delta phi equal to half B naught V naught L for beta equal to 0. Now this equation comes to the picture. Equation is B equal to B naught 1 plus Y by L. 1 plus Y by L to the power beta. है ना? So induced EMF will be what? B L V naught. If beta is equal to 0, this becomes 0. So B becomes B naught. So induced EMF is B naught L V naught. Induced EMF is B naught L V naught. Okay. Beta 0. So B is constant. What they are saying? Half B naught V naught L. Wrong. So answer will be B naught V naught L. है ना? D. If beta equal to 2, then delta phi. See, why I am finding E, because E will be directly proportional to delta phi, है ना? Delta phi by delta t. है ना? Or E dt you can write, है ना? Okay. Option D for beta equal to 2. So if B equal to B naught 1 plus y by L square. This is B. Now in this case, you have to take for induced EMF, consider this rod at a distance of y, take a small element dy. So induced EMF will be B naught 1 plus y square by L square, y square by L square into dy BL V naught, है ना? So induced EMF will be what? B naught V naught dy plus B naught by L V naught by L y square dy y square dy. From where to where? 0 to L, 0 to L. So induced EMF will be B naught V naught L plus B naught V naught by L into L cube by 3. Okay. L square was there, sorry, L square. Okay. So you get B naught V naught L plus B naught V naught L by 3. So you get 4 B naught V naught L by 3. Okay. So delta phi will be obviously proportional to that. Okay. Delta phi, I think they're taking for 1 second or what? Okay. So if induced EMF is this, delta phi will be 4 by 3 B naught V naught L. Okay. Delta T take 1 second. So fourth one is also correct. Fourth one is also correct. Okay. So I am using the concept delta phi will be proportional to EMF. Fourth one is correct. Okay. Ninth one. A 10 centimeter long perfectly conducting wire PQ is moving with velocity 1 centimeter per second. On a pair of horizontal rails of zero resistance, one side of the rail is connected to inductor L equal to this and R is 1 ohm as shown in the figure. The horizontal rails L and R lie in the same plane. B is given. Okay, so whenever this switch AS is closed, current in the circuit after 1 millisecond is this. Okay, so here you can see the velocity is constant. V is constant. Okay, assume the velocity of where PQ remains constant. Very important, huh? So I'm applying some external force, otherwise it will decrease, you know that. So if velocity is constant, so I can consider this as LR circuit, L, R with a constant EMF, E. Okay. What is E? Equal to BLV. So can I use growth of current? Growth of current. Growth of current is what? I equal to I naught 1 minus e to the power RT by L minus RT by L. Okay. So what is I? I equal to I naught is E by R. At steady state, it will be E by R. Okay, E is BLV. 1 minus e to the power R is 1 into T is 1 millisecond, 1 into 10 to the power minus 3 divided by L is 1 into 10 to the power minus 3. 1 millisecond they told. Hmm? So is BLV by R 1 minus e to the power minus 1. So you get I equal to BLV by R. BLV, B is 1, L is the length, huh? BLV 10 centimeter, B is 1 and V is again 1 centimeter per second. Okay. B is 1, length is 0.1 and 0.01. है ना? 1 minus 1 by E, you know that this is 0.63. So 0.63 into 10 to the power minus 3 answer. So answer is 0.63. Correct. Okay. Yeah. Question number 10. A light disc made of aluminium in non-magnetic material is kept horizontally and is free to rotate about its axis as shown in the figure. A strong magnet is held vertically at a point above the disk away from its axis. On revolving the magnet about the axis of disk, the disk will. If I revolve this magnet about its axis, so what will happen? See, the condition is here there is a disk, aluminium conductor. Okay. Now because of magnet, there will be a field, magnetic field, not pole, so going into the plane like this. Now, this is due to magnet. When this magnet comes here, if it is rotated, okay, what will happen? If it is rotated about this disk, what will happen? Magnetic field will change. So at A and at B, I am considering. So what will happen? At A, the magnetic field will change. And because of that change from the surface of a metal, if magnetic field is changed, what will happen? AD current AD current will develop. That AD current will oppose. That AD current will oppose. Is that clear? Okay. So if AD current tries to oppose, so what will happen? Now from A the magnetic field is decreasing and the magnet is moving this side. So what will A try to do? A will try to move to this place. Okay, because it doesn't want any change in magnetic field. Try to understand. Initially it was just above A, so from A there is a magnetic field. Now it goes to another point. So what will happen? A will also go to that point because through this cross section A, magnetic field, it will want that magnetic field should not change because of eddy current. What will happen? It will rotate. So if I rotate the bar magnet, this disc also tries to rotate in the same direction. So this answer is correct. Option B. Rotate in same direction as the direction of magnet's motion. Okay. Is that clear? And also temperature will rise because of eddy currents. Okay, so option D is wrong because they told not rotate, which is absolutely wrong. It will rotate and temperature will also rise. So if they give another option, rotate and temperature rise, then that will be the perfect answer. Okay, because of eddy current, some temperature will rise. C is also wrong, not rotate. Rotate in opposite direction, A is also wrong. B is correct. Question number 11. A circular coil of radius r and capital N turns has negligible resistance connected to a wire. The wire is connected to capacitor charged with Q through a switch. Coil is in horizontal uniform magnetic field is B naught parallel to the plane of the coil. When switch is closed, the capacitor gets discharged through the coil in a very short time By the time capacitor is discharged fully, magnitude of angular momentum gained by the coil. So what will happen whenever this switch is short, okay, closed basically, capacitor is initially charged with Q naught plus Q naught minus Q naught, I can say. What will happen? Capacitor will discharge. You can consider Euler circuit. One. Only one loop is there, although. Okay. So capacitor will get discharged, so there will be a current. Now, as soon as there is current in the loop, there will be torque. Okay. So because of torque, there will be angular momentum. Okay. So what I can write torque equal to M cross B. Total number of turn is capital N. Hmm? N turn. Okay. So it's N turn, not one turn. I was saying one turn. N turn. N number of turn is there. So what is magnetic moment? You know, I current flows through that into pi rs. Magnetic field is B naught into M. Torque is what? I alpha. So I d omega by dt equal to n B naught pi r square I. So I d omega equal to n B naught pi r square I dt. So if I integrate, integration of I dt will be what? Q. So I omega equal to n B naught pi r square Q naught. This is Q naught, इंटीग्रेशन ऑफ आई डी टी. ओके. सो अब देखो जो भी आंसर है, आंसर पाई एन बी नॉट आर स्क्वायर, पाई एन बी नॉट आर स्क्वायर क्यू, बी स्क्वायर. चार्ज इज क्यू, नॉट क्यू नॉट, चार्ज इज क्यू है ना, चार्ज इज क्यू. ओके फाइन. नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 12. The inductors of two Euler circuit are placed next to each other as shown in the figure. The values of self-inductance of inductors, resistance, mutual inductance, and applied voltage are specified in the given circuit. After both the switches are closed simultaneously, the total work done by the batteries against the induced EMF in the inductors by the time current reach their steady state. Okay. So suppose I consider current in circuit 1 is I1 and current in circuit 2 is I2. What is E1? E1 is L1 d I1 by dt plus, due to mutual inductance M di2 by dt. Okay, induced EMF. Okay, induced EMF in circuit 1. What is dw by dt? dw1 by dt. Power, correct? Well done. So power is Vi. So can I write E1 into I1? Okay. Similarly, what is E2? Little complex question this is, okay. First time you are hearing, so it will look like little complex. di2 by dt plus mutual inductance, that will be proportional to di1 by dt. So what is dw by dt? dw2, work done in circuit 2 by the battery. E2 I2, okay. So from here, can I dw1 equal to L1 E into I1, na? So I'll get L1 I1 di1 plus M I1 di2. dt cancel, okay. What is dw2? dw2 will be E2 is L2 I2 di2 plus in D I1 and I2. So if you add dW1 plus dW2, you'll get, add and integrate, okay? Half L1 I1 square. Just integrate. है ना? I1 d I1. So I1 square by 2 plus half L2 I2 square plus M I1 I2. Okay. Now put the value of L1 I1 I2. Okay. So you'll get basically you get that is equal to 55 millijoule. Okay. Put the value of I1 L1 steady state current. Okay. Question number 13. A long straight wire carries I equal to 2 ampere. Here I equal to 2 ampere. Straight wire. Semicircular conducting rod is placed beside the conducting parallel rails of negligible resistance. Both the rails are parallel to the wire rod and the rails in the same horizontal plane as shown in figure. Two ends of the semicircular rod are at a distance 1 and 4. Rod starts moving with 3 meter per second. Resistance is there, capacitor is there. So basically RC circuit. Huh? So you can replace this as this is EMF, this is R, and this is C naught. Now what will be this EMF? This EMF you have to calculate. For that you take the projected length and try to calculate the EMF. So first I'll calculate the EMF. EMF induced. Straight wire current is 2 ampere. Projected length I'll take like this. Now magnetic field is not constant. Magnetic field is not constant. So what I'll do, I'll take a dx at a distance of x. What will be d? D will be b dx into v integrate. B is what? Mu naught I by 2 pi x. This is v now. V naught I by 2 pi x dx into v. So mu naught IV by 2 pi integration of dx by x, which you'll get in this EMF you'll get mu naught is 4 pi into 10 to the power minus 7, I का value 2, B का value 3 divided by 2 pi into ln integration of dx by x is from where to where 1 to 4. So you get ln of 4 by 1. So I can get 2 ln 2. है ना? 2 ln 2. 2 to cancel, pi cancel. So ln 2, I think ln 2 value they have given 0.7 है ना? So 4 फटाफट करो 4 into 3 into 2 into ln 2 10 to the power minus 7. So you get from here you get 8 into and 0.7 is also there. So you get 1.68 no 12 into 2 into 0.7 24 into 0.7 you get 16.8 into 10 to the power minus 7. So once you got this, what is the current in the circuit? Current is E by R. So लिखो 16.8 divided by R, they have given 1.4 ohm. 1.4 into 10 to the power minus 7. So that is 12 into 10 to the power minus 7. 1.2 into 10 to the power minus 6. I. What is Q? Q is C naught into E. So 1.68, no, 16.8. थोड़ा सा गलती कर रहे हैं यहाँ पे 16.8 होगा 16.8 into 10 to the power minus 7 into 5 microfarad. 5 into 10 to the power minus 6. So you get 8.4 into 10 to the power minus 12. This is the answer. Okay, Q charge. This is I. So 1.2 into 10 to the power minus 6. Correct charge is C. Correct. So A and C is the correct answer. Okay. So last two questions. Special metal S conducts electricity without any resistance. A closed weld loop made up of S does not allow any change in flux through itself by inducing a suitable current to generate a compensating flux. The induced current in the loop cannot decay due to its zero resistance. The current gives rise to a magnetic moment which in turn repels the source of magnetic field or flux. Consider such a loop of radius A with its center at origin A. Magnetic dipole moment M is brought along the axis of the loop from infinity to a point R from the center of the loop with its north pole always facing the loop as shown. The magnitude of magnetic field of a dipole M at a point on its axis at a distance R is this. So this is given. आपको पता है magnetic dipole moment, magnetic field due to dipole, where mu naught is the magnitude of force between M to separate by distance R axis. Force is given K A1 M2 by R to the power 4. That is the force, where K is a constant. The direction of this force along the line joining the two dipoles. When the dipole M is placed at a distance R from the center of the loop, the current induced in the loop. Okay, so this is the loop. This is the loop of radius A is at a distance of R. There is a small dipole moment of M. Okay, when the dipole is placed at a distance R from the center of the loop, the current induced. Okay, so can I find what is flux? Flux, flux through loop. Flux is what? B into area. B is what? B is given mu naught by 2 pi m by r cube into area is what? Pi into a square. This is the flux. Okay. And this flux is the cause of induced current. Okay. So whenever flux through this is changing, what will happen? There will be induced current. Okay. So can I write phi equal to L I? Okay. So what is phi? What is I? I is phi by L, which is mu naught by 2 pi m by r cube pi a square by L. So I is directly proportional to m by r cube. Which option? Yeah, option A is the correct. Okay, then option A is correct for 14. For 15, work done to bring in from some distance. Okay, so what is the force they have given? Force they have given, force is equal to K m1 m2 by r to the power 4. m1 m2 by r to the power 4. Now for this, due to induced current, the magnetic field will repel, na? Due to dipole moment, magnetic field on this side, and due to induced current, it will repel. Correct. So what will happen? There is a force in this direction. So I have to apply some external force opposite to it to do the work. So my work done will be work done against the force of magnetic field. Okay. So what is dW? dW will be FB, force due to magnetic field of this loop, है ना? dr cos of 180. It doesn't matter because they are asking only the proportionality. Correct. What is FB? K m1 m2 divided by r to the power 4 dr cos 180 is minus 1. K m1 is m. What is m2? Magnetic moment of the loop. I into area, correct? I into area divided by r to the power 4 dr. K m. What is I? I will be directly proportional to m by r cube. Here it is r to the power 4 divided by r to the power 4 to dr. So basically, if I integrate directly proportional to m by r to the power 7 dr. So if I integrate this, so m square by sorry m square divided by r to the power minus 7 plus 1 by minus 7 once again r to the power minus 7 plus 1 divided by minus 7 plus 1. So you get directly proportional to m square by r to the power 6. ठीक है तो देखो ऑप्शन सी इज द करेक्ट ओके थैंक यू वेरी मच ऑल द बेस्ट फॉर योर एग्जाम थोड़ा सा लेट हो गया उसके लिए माफी चाहता हूँ ठीक है